In the existence and uniqueness theorem, they guarantee you a unique solution to a differential equation in a particular interval. In this video, I want to talk about why it's important to stay in that interval and what happens if you go outside the interval. So let's start just by this. Take a look at the integral of 1 over x dx. I think most of you would agree that the integral of 1 over x dx is equal to the natural log of the absolute value of x plus a constant. Is this the general solution? Right? Is this all of the solutions to that integral? Is these all the antiderivatives of 1 over x? Well, I've graphed a few of them here. Absolute value of x, natural log of the absolute value of x plus 0 is the black one. I think with c equal to -2 is the blue one, and with c equal to 4 is the red one here. Right? So all of those for different values of c look like this, just shifted up or down. That's the whole point, right? However, there is an asymptote here at x equals 0. And technically, there's more solutions because I could add different amounts on different sides of that asymptote. So for instance, the picture down here, on the right-hand side, I've added 0. But on the left-hand side, I've added, well, this one is 0, but the next one up is +1, and this one is +2. So I could take the right-hand side with any one of these on the left-hand side and still have a function whose derivative is equal to 1 over x, because the shifting up and down doesn't change the derivative. So I can shift differently on different parts of that graph because there's a discontinuity. There's a vertical asymptote. You do one thing on one side, one thing on the other side. So if I take a look at this differential equation right here, y prime equals 1 over x with y of 1 equal to 0, this is a first order linear differential equation. P of t, actually I guess P of x, I'm using x here. P of x is equal to 0, and the g of x is 1 over x. And with my initial condition, y of 1 equals 0. This is first order linear. The theorem guarantees a single solution, right? But if I say, look, here's a solution, I take it right like that, and on the left-hand side, I use the bottom one here, or I say, no, look, here's another solution. It looks like this on the right, and it looks like the top one on the left. Is that two different solutions for the same equation? Yes, it is. However, in the interval where p and g are continuous, there is only one solution, right? In that the g here is 1 over x. It has an asymptote at 0. The initial condition has x equals 1. So the interval that contains the initial condition where the functions p and g are continuous is from 0 to infinity. It doesn't include the stuff on the negative side. It only includes the stuff on the positive side. So in that interval, there's only one solution. Okay, so that's the importance of staying in that interval. Once you get outside of the interval, who knows what happens? Because when you go over those points of discontinuity, then you can be shifting the function different amounts and make it look like you've got different solutions. But in the interval of continuity, one solution and only one solution.